Fairly quick video I wanted to make. It seems like I've been doing a lot of those lately. This is really just kind of a cleanup video that I wanted to do so I can clean up all this junk on my bench and get to my next project. Anyway, I was fooling around with this this oven controlled oscillator here. It's an 1813, let's see, 1813-0644 oven controlled oscillator. It's actually made for this spectrum analyzer here, but I need a counterlock board for it to work, otherwise you can't connect it, and the counterlock boards are fairly expensive, so I don't know what I'm going to do in that case, but I just thought I'd mess around with it and try to showcase a little bit of other things that I did. First of all, this is the HP DC quad power supply, which I fixed. I ran some cables out to the front so that I could connect it and use it up front rather, because all the connections are on the back. But there's some information, I think, on my YouTube about fixing this thing. If not, it's on the EEV blog. I think most of it actually is on the EEV blog for fixing this, although I might have some other information or a quick one. It was rather an interesting repair, so have a look at the EEV blog, or maybe I'll put a link, I don't know. Anyway, the point is that I just wanted to, for reference sake, show this and give a little background. I had to figure out the pinouts on this, so maybe it'll actually help some people. This is basically what I figured out. There's 3 pins that are in succession, fairly close together, so we'll just call that one pin 1. That's an enable pin. Next is ground, then the heater, and then the oscillator. Basically, the voltages are around 5 volts for the oscillator, 15 volts for the heater, although there is some range on that, and then of course ground is ground. The enable pin basically is a way of enabling the oscillator. It's used for various things, but in this case I basically just connected the enable to the heater, and a lot of times that's what it's used, is that if the heater is not getting any power, it doesn't oscillate, because I assume it's supposed that it's not going to be stable. Anyway, this thing at 15 volts, you could tell it's running 130 milliamps right now. On the 5 volt supply, it's running about what, 10 milliamps roughly. You know, it's basically showing a negative because it's just so low that it really can't. It doesn't have the resolution to really tell. It's not that this thing is out of calibration. I calibrated it just fine. And it's not that it isn't working. It's just the amount of current draw is so small that it really just can't register. And on here, when it's originally turned on, before it heats up, it registers about a half of amp, and then drops down to this 130 milliamps. Anyway, I have it connected to my my very accurate. Now this counter does not have a oven controlled oscillator, so it's not as accurate as it could be, but it is very accurate. And as you can tell, it's about 6 hertz off. So that's kind of the video. It's just kind of showing if anybody needs this information. This is the pinout on this thing, and this is the way it works. So and actually you can feel it, and it's a little warm, so the heater is working. About 7 hertz off, which if you look at that as parts per million, that's really quite good. So this is the video, kind of short. I'm going to clean all this up and then get to my next undertaking. Hope you all enjoyed it. Thanks.